Assalamu alaikum. It's Ahlam Deeb, and I'll be explaining Chapter 2, Rate of Reactions, Part 3. Before we start, please prepare your stuff. These are the objectives of our video for today. You know from the previous video that the rate of the reaction during an interval of time is called average rate. Today, we are going to identify the instantaneous rate of a reaction. You also know that to determine the average rate of formation of a product within an interval of time delta T equal T2 minus T1, we have to choose 2 points on the kinetic curve of the product. These 2 points must have as abscissa T1 and T2. We join these 2 points by a straight line, and the average rate of formation of the product during delta T will be equal to the slope of the secant equal to y of B2 minus y of B1 over x of B2 minus x of B1. The same to determine the average rate of disappearance of a reactant within an interval of time delta T equal T2 minus T1, we have to choose on the kinetic curve of this reactant 2 points having as abscissa T1 and T2. We join these 2 points by a straight line, we get a secant, and the average rate of disappearance of the reactant within this interval of time will be equal to the negative slope of the secant equal to minus y of A2 minus y of A1 over x of A2 minus x of A1. The instantaneous rate of a reaction is the rate of a reaction at a specific instant t. It is defined as the limit of the average rate as delta t tends to 0. So the instantaneous rate is the limit of delta concentration over delta t, or the limit of delta n over delta t when delta t tends to 0. Dear students, you have to memorize that graphically, the instantaneous rate of reaction is the slope of the tangent to the curve at the point of abscissa T. How is that? Let's see. For the reaction seen in the previous videos, the reactant A gives product B. This is the kinetic curve of product B. To determine the instantaneous rate of formation of product B at T equal to 100 seconds, for example, we write the instantaneous rate of B at T equal to 100 seconds is equal to, on the curve, we draw a tangent at T equal to 100 seconds. We choose 2 points on this tangent, B1 and B2. We determine the coordinates of B1 and B2, and the instantaneous rate of formation of B2 at T equal to 100 seconds will be equal to the slope of this tangent equal to y of B2 minus y of B1 over x of B2 minus x of B1. So what we have to memorize is this. The instantaneous rate of formation of product B at T equal to 100 seconds is equal to the slope of the tangent at the curve, concentration of B equal f of T at the point of abscissa T equal to 100 seconds. For the same reaction, A gives B. To determine the instantaneous rate of disappearance of A, which is a reactant, at T equal to 100 seconds, we draw the tangent to the curve at T equal to 100 seconds. We choose 2 points on this tangent, A1 and A2. And the instantaneous rate of disappearance of A at T equal to 100 seconds will be equal to the negative slope of the tangent equal to minus y of A2 minus y of A1 over x of A2 minus x of A1. The negative here is because this fraction will give us a negative value, and the rate has always positive value. So what we have to memorize is that the instantaneous rate of disappearance of reactant A at t equal to 100 seconds is equal to the negative slope of the tangent of the curve concentration of the reactant equal f of t at the point of abscissa t chosen. Here we have chosen t equal to 100 seconds. What about the instantaneous rate of the reaction at t equal to 100 seconds? The instantaneous rate of the reaction at t equal to 100 seconds is equal to the instantaneous rate of disappearance of A at this instant, or it is equal to the instantaneous rate of formation of B at this instant. So, in general, for a reaction where the reactants and the product have stoichiometric coefficients different than 1, and for an instant t chosen, we can say that the instantaneous rate of the reaction is equal to the instantaneous rate of disappearance of the reactants over the stoichiometric coefficients, or it is equal to the instantaneous rate of formation of the products over their stoichiometric coefficients. Always remember that the rate of reaction has a positive value. How does the instantaneous rate of reaction vary with time? Let's see. Here we have the kinetic curve of the product B. We have drawn on this curve 3 tangents, 1, 2, 3. We give the definition of the instantaneous rate by saying the instantaneous rate is equal to the slope of the tangent at the curve, and we see that the slope of the tangent is decreasing with time. So alpha 1 is bigger than alpha 2 is bigger than alpha 3, so the rate of reaction decreases with time. If we are given a kinetic curve of a reactant, we also draw 3 tangents. We give the definition by saying the instantaneous rate is equal to the negative slope of the tangent, and we draw the slope, and by saying the negative slope of the tangent decreases with time, alpha 1 is bigger than alpha 2 bigger than alpha 3, so the rate of reaction decreases with time. Please always remember that for all reactions, rate decreases with time. For each chemical reaction, there is an instant t at which the evolution x is equal to x maximum over 2. We have the same reaction seen previously. Let's try to find the half-life of this reaction. Is your answer 250 seconds? Sorry, it's wrong. Why? Since t half is not half the time to reach x maximum. It is not 500 over 2. It is not 250. Always remember that t half is less than t of the reaction over 2. Why is this? Simply, we have seen before that the rate of reaction decreases with time, and it is maximum at the beginning. So the consumption of the first half of the limiting reactant will take less time than that of the second half. Therefore, for all reactions, t half is less than t of the reaction over 2. So what is t half of this reaction? Let's see. T half can be determined graphically by referring to the kinetic curve of the product. By definition, T half is the time needed for the formation of half the final or the maximum amount of the product. Let's see. This is the kinetic curve of the product B. The maximum amount reached by B is 1.7 mol per liter. This is B at infinity. So B at T half, according to the definition, will be equal to B at infinity over 2. It's equal to 1.7 over 2 equal to 0.85 mol per liter. Graphically, for B equals 0.85 mol per liter, T is equal 100 And so T half is equal to 100 seconds less than 250, which is T of the reaction over 2. Always remember this. Can T half be determined by referring to the kinetic curve of the reactant? Yes. Let's see. Also, we have another definition for T half. T half is the time needed for the consumption of half the initial amount of the reactant. So, the reactant A here, this is the kinetic curve of reactant A. The initial amount of A is 1.7 mole per liter. So, by referring to the definition, the concentration of A at T half will be equal to the initial concentration of A over 2 equal to 1.7 over 2 equal to 0.85 mole per liter. So graphically, for A equal 0.85, T half will be equal to also 100 seconds. If the reaction contain more than one reactant, and the mixture of reactants is not stoichiometric, T half is defined according to the limiting reactant. Let's do an application for these information. Number 4 of the sheet. Please take 3 minutes to solve part A. The solution of part A. According to stoichiometry, the instantaneous rate of N2O over the coefficient, the stoichiometric coefficient 3 is equal to the instantaneous rate of disappearance of C2H2 over 1 equal to the instantaneous rate of formation of N2 over 3 equal to the instantaneous rate of formation of CO over 2 is equal to that of H2 over 1. We want to calculate the instantaneous rate of each reactant. So for N2O, we find a relation with the instantaneous rate of formation of H2O given here. So we write the instantaneous rate of disappearance of N2O is equal to 3 times the instantaneous rate of formation of H2O equal 3 times 0.1 equal 0.3. Don't forget the unit. It is mole, liter minus 1, second minus 1. For C2H2, the same, we will get 0.1 mole, liter minus 1, second minus 1. For N2, the instantaneous rate of formation of N2 at instant T is equal to 3 times that of H2 equal to 0.3 mole, liter minus 1, second minus 1. And also this is the instantaneous rate of formation of CO. Now, part B of the question. Please take 2 minutes and solve it. The solution of this part is the rate of the reaction at instant T is equal to the rate of disappearance of the reactants over their stoichiometric ratio equal to the rate of formation of the products over the stoichiometric ratio. We will use this one to calculate the rate of the reaction, which will be equal to that, to the rate of formation of H2O equal to 0.1 mole, liter minus 1, second minus 1. This is the end of our session for today. This is the summary that you have to write on your chemistry copybook. And here is your agenda. See you soon in the next video. Wassalamu alaikum.